Hello, friends. Welcome to all of you in our lecture series of frequency modulation. Dear friends, today we are going to discuss a new topic in the frequency modulation, and the name of the topic it is effect of modulation index on the frequency spectrum of FM. So, after listening or watching this video, you are able to understand the meaning of significant amplitude sidebands and its effect on calculation of the bandwidth of FM. So, before moving to that particular part, let us have a look over the definition of frequency modulation first, and then we will move towards the discussion on effect of modulation index on the frequency spectrum of FM. So dear students, as per our previous discussion, if we define the frequency modulation, so frequency modulation is the process in which frequency of the carrier gets changed in accordance with instantaneous change in amplitude of the modulating signal by keeping phase and amplitude of carrier constant. So, in frequency modulation, as the instantaneous amplitude of the modulating signal gets changed, so in accordance with that change in instantaneous amplitude of the modulating signal, the frequency of the carrier gets changed. So, when there is no any amplitude change available or observed in your modulating signal, at that time carrier frequency is constant, so there is no any frequency change in the carrier. But as the instantaneous amplitude of the modulating signal goes on increasing, frequency also increases. So at peak positive amplitude, there is maximum frequency we are observing. At peak negative amplitude, we are observing minimum frequency. So as amplitude goes on decreasing, frequency also decreases. Now in our previous lecture, we discussed about the time domain and frequency domain representation of FM. So whatever the diagram here you are observing, it is a time domain representation of the FM. Now if we want to observe the frequency domain representation of FM, so diagram is in front of you. So in frequency domain representation, on x-axis there is a parameter frequency and on y-axis the amplitude is present. But in your time domain representation, on x-axis there is a term time and on y-axis there is a term amplitude. So these two representations we discussed, that is time domain and frequency domain representation. So if we summarize this discussion, we conclude one thing is that as the amplitude, instantaneous change in amplitude of the modulating signal takes place, frequency of the carrier gets changed. So we can say that as the amplitude of the modulating signal varies, the frequency deviation will change. So whatever the initial frequency of the carrier itself gets changed. So number of sidebands are produced, and these sidebands are always infinite in numbers. So in FM we say that the total number of sidebands are created, it may be a infinite number. Now here we are taking two examples to understand the effect of modulation index. Now in these two examples we are taking, suppose the value of modulation index MF equal to 1, and second we are taking the example if the modulation index it is of 2. So MF is 1 or MF is 2. So for that particular value of modulation index, how the frequency spectrum it is drawn. So let us have a look over the frequency spectrum with modulation index MF equal to 1. So as our description, as per our description, we say that in frequency domain representation on x-axis there is always a term that is frequency, and on y-axis there is always a term that is called as amplitude. Now this amplitude has a major role to decide the significant bands. So suppose I am drawing a frequency domain representation. So here I am writing frequency domain representation of FM with modulation index MF equal to 1. So at that time, whatever the spectrum I am drawing, it is just like this one. So it is your carrier frequency. Then this point it is Fc plus Fm. Here Fc plus 2 Fm. Then here Fc plus 3 Fm. Similarly in this direction Fc minus Fm, Fc minus 2 Fm and Fc minus 3 Fm. So the sidebands in this direction labeled as upper sideband USB, and sidebands in this direction always labeled as LSB. Right. Now here we are observing that the amplitude of these two sidebands are having a significant amplitude. So significant amplitude means the amplitude which have some significant value. So if we compare the upper sideband 1, then the upper sideband 2 and upper sideband 3. So the upper sideband 1 has a significant amplitude, that is more amplitude than that of your upper sideband 2 and 3. So upper sideband 2 and 3 are not having that much significant amplitude. So while calculating the bandwidth, we are always considering the band or the USBs or LSBs of significant amplitude. So whatever the sidebands created with significant amplitude, only those sidebands are always taken into the consideration while calculating bandwidth of FM. So similarly in the case of LSB, the lower sideband 1 has a significant amplitude than that of your lower sideband number 2 and lower sideband number 3. So in such a case, we always say that while calculating the bandwidth of FM, we are taking or considering the significant band or amplitude band, that is 1 LSB1 and USB1. So this is the frequency domain representation of FM with MF modulation index equal to 1. Now let us have a look over the second example in which we are drawing the frequency spectrum with modulation index 2. So similarly, on x-axis there is a term frequency, and on y-axis there is term amplitude. So I am just trying to draw the frequency spectrum of a FM with MF equal to 2. So here it is FC plus FM, then FC plus 2 FM, then FC plus 3 FM, and last FC plus 4 FM. Similarly, all these are nothing but the upper sideband USB. Similarly, here it is FC minus FM, FC minus 2 FM, then here FC minus 3 FM, FC minus 4 FM. Right. So it is upper sideband 1, upper sideband 2, upper sideband 3, upper sideband 4. Then lower sideband 1, lower sideband 2, lower sideband 3, lower sideband 4. So these are nothing but the sidebands created. So we can label it as a frequency domain representation of FM with modulation index MF equal to 2. So we can say that as the amplitude of the modulating signal increases, total number of sidebands created also increases. So we say that if there is a higher value of MF, so if the value of MF goes on increasing, more number of sidebands will be created, and in further way we can say that the sidebands having significant amplitudes goes on increases. So for MF equal to 1, the sidebands with significant amplitude are less, but when MF equal to 2, in this frequency domain representation we observe that the number of sidebands having significant amplitude goes on increasing. So this number of significant sideband term, it is very much useful while calculating the bandwidth of FM. Now dear student, always keep in mind that in AM we say that there are only two sidebands, one LSB and one USB. So if we want to calculate the bandwidth of AM, then it is very much simple. So USB here, and here it is LSB. So upper sideband minus lower sideband gives me the bandwidth of FAM. So higher frequency minus lower frequency gives me the bandwidth of AM. But if in case of FM, the total number of sidebands are infinite, then question arises in front of us, how to calculate the bandwidth if the total number of sidebands are infinite. So for the calculation of the bandwidth of FM, we are considering the sidebands, only those sidebands which are having a significant amplitude. Okay, so now let us have a look over a bandwidth calculation of FM. So bandwidth calculation of FM. So there are two ways to calculate the bandwidth of FM. First one, it is ideal bandwidth. So we are discussing about ideal bandwidth of FM, and also we are talking about practical bandwidth of FM. So when we say that ideal bandwidth of FM, then this bandwidth is defined as frequency difference between highest pair of sidebands. So ideally the bandwidth of FM, it is infinite because total number of sidebands are infinite. So if we take the ideal condition, so ideally the bandwidth of FM, it is infinite because the total number of sidebands are infinite. But when we want to calculate practically the bandwidth of FM, so here the word comes practical. At that time we are considering the significant amplitude sidebands. So there are two methods to calculate the practical bandwidth of FM. So first method, it is nothing but bandwidth is equal to twice FM multiplied by number of significant sidebands. This is the first method. Significant sidebands, or we can say that number of sidebands having significant amplitude. So bandwidth of FM can be calculated, practical bandwidth of FM can be calculated by the first method, that is bandwidth is equal to twice FM multiplied by number of significant sidebands. So FM, it is nothing but the modulating frequency, right? So frequency of the modulating signal, and number of significant sidebands means the sidebands having significant amplitude. So suppose if MF equal to 1, the number of sidebands having significant amplitudes are 2. Similarly, if MF equal to 2, the number of sidebands having significant amplitude are 4. So 2 from lower sideband, 2 from upper sideband, right? Now the another method to calculate the practical bandwidth of FM, it is with the help of Carson's rule. So Carson's rule gives us the information about how to calculate the practical bandwidth of FM. So the formula for that, it is bandwidth is equal to twice into bracket delta plus FM max. So where delta, it is the frequency deviation, right? And FM max, it is the maximum modulating frequency. So these Carson rules gives us a better result or the correct result if the modulation index, it is greater than 6. So Carson's rule, it is applicable for the frequencies or the calculation of the bandwidth for the frequencies or FM modulated signal with your modulation index, it is greater than 6. So this is all about the bandwidth calculation of FM. So in our today's lecture, we discussed about the bandwidth calculation of FM. So ideally bandwidth of FM it is infinite, but practically it can be calculated by two methods. So bandwidth is equal to twice FM multiplied by number of significant sidebands, and second method it is through the Carson's rule, in which bandwidth is equal to 2 into bracket delta plus FM max. If MF equal to 6 or more than 6, then we can get the accurate result of your calculation of bandwidth. So we will stop here. So thank you very much.